Hi, in this video, I will explain you the two-sum problem and its solution in Java. So you can find this problem details in the lead code as well. It is the problem is taken from the lead code. So the description wise, so they will give you the list of numbers, okay, array of numbers, and then they will give one target as described here. So you need to find out the indexes of the two integers whose summation is equal to the target. So that is the problem. So we have given you the examples here, different examples, 1, 2, and 3. You can just treat them. They are very pretty trivial. So you can assume that there will be only one solution, not more than that for the target. So if you give a target, there are only two indices such that whose sum is equal to the value. Now, so if they are not present, you can say it's not present. So there are not duplicate, or you can assume that the same number should not be added. Say if the target is 4, you cannot give the 2 plus 2 equal to 4 because they are at the same index. So you should find out the two unique indices whose sum is the target, or the value at that index should be equal to the target. And you can assume that the array index starts at 0 index and proceeds towards n minus 1, where n is the number of inputs, okay, in the numbers array. So that's a problem description. So there are multiple solutions for this. So we will find out the best with respect to the time complexity. So we'll discuss about that one. And the solution for this is already available in the GitHub that I've added here. So if you want to directly check out the problem and explore on that, you can just check out this location, and there you can find the solution under the two-sum module. Okay. For your explanation, so for your understanding, I will just create a new project and then add the solution for this one. Okay. So let us create a new project for this in the IntelliJ. So this new project. So the name is two-sum solution. Okay. So you can choose any location, basically the directory where you want to store the solution, and the language was Java language. Build system is Maven. So you assume that you know the little bit details about Maven. Even if you don't know, you just take it for granted. There is no need to know the details about that. And let us say create. So it will just create the sample program for you. So it is a sample thing. There will not be anything else, and the test folder will be empty. So what I do here now, I will change the package to com.jk.example.twosum. So I am just changing the package to my own package. Okay. So let us change this. So here I will create a new class. I'll say some problem. Okay. So here we will add a method called public void find indices. It will take two integer one is integer array, the list of numbers, okay, the input numbers. The another one is the target. Say we will say twosum, okay, int twosum, just to indicate that the sum of two numbers. Okay, so that is the input. So we will need to write an integer array as the solution with two indices as part of that one. Okay. So now let us say we will see the index equal to 0, index equal to less than or equal to numbers dot length. So we will iterate through all the numbers, okay, and then say index plus plus. Here we will define a map. Okay, just to hold integer. It is hash map numbers index map. Say equal to new hash map. Okay. So the reason why we are declaring the numbers index map is that number index map. So the key will be the number that we encounter here in the for loop. And the second one is the index where that particular number is, because we are our numbers is array of numbers, right? So while iterating through these numbers, when we encounter a number, we will add it to the map along with its index to later search whether that particular number is present in the map or not. So the reason why we go for map is that its operations are order of one. So if you want to add an element to the map, the integer implementation for equals and hash code will take care of such a way that the time needed for adding the number to the map and getting the number from the map or searching for a number in the map is order of one constant because of the hash code functionality. Okay, that is the reason we go for map to get the order of one time for searching, finding, searching, adding, as well as getting the number. So that is the thing. Okay, now, so this for loop will iterate through all the numbers till we find the indices whose sum is equal to or two sum. Okay, so let us say the first number that we are first number. Say okay, first number, anything you can name it anything here as per your choice. First number equal to numbers of index. The current one that we are iterating is the current number. Okay, and we know that to sum. Okay, the second number that we need is second number equal to two sum minus the first number. We know that the target is what we need is first number plus second number should be equal to two sum. So that is the thing. So that's why we don't know the second number yet. The current that we are iterating is assume that as a first number. So the second number is two sum, the target minus first number is the second number. Okay, and the first number index already we know. First number index equal to index. Now we need to find out the indexes, right? Not the actual number. Within the array, we need to find out the place where that number is present. So we are naming it as index. So the second number is two sum minus first number. Now let us see this number index map. If it is already containing this number, okay, in the first number when we iterate through the first number, this will be empty. Okay, it will not have anything. So we'll say if number index map dot contains. So there is a method called contains key and map API. So if you give a input element, it will search for that element in the map. If it is present, it will say true. If it is not present, it will return false. Okay. When during the first iteration, it will always give false because this is empty. So contains key of second number. We are searching for second number because first number we already know the current one that we are iterating. Second number we don't know where it is present in the input array. Okay, so contains. So assume that this is already present. Okay, this map is already empty and present. Okay, in case if it is containing that key second number, we will get the index. Okay, int second number index equal to, you just get number index map dot get of first number, sorry, second number. Okay, so in case if it is already present in the second number is present in the map, then we know what is the index, can get the index. And now you return new integer array with numbers, first number index and second number index. So these two indexes we will return. Okay. In case if it is not present in the map, okay, the second number is not present in the map, then we put the first number into that map, because first number we have iterated. So we'll put that first number back into the map number index map. So number index map dot put, the key is the number, first number. In the second one is the index. Okay. First number index. Okay. That's it. So this is the for loop. Okay. And in case if it comes out of this for loop, then it will return null, because we have not found anything through this one. So this is one version. Okay. If you want to simplify it further, okay, if you want to, if you, for easy understanding, we can say it as V2. Find indices, say it is V1. Okay, this is version 1, and this is another way. So here, once you create a map, so here itself you can iterate through all the elements. Index equal to 0. Index is less than numbers dot length index plus plus. So you can just push everything into the map as in the first loop. Okay, and put up now the number, that is number of index. Okay, and then the index. Numbers of index. Okay. So what will happen here in this for loop? It will add all the numbers into this map along with this index. So what is the number? What is its index? Okay, like that it will add all the numbers into the map. Okay, and then here when we come here, we'll get the first number. Second number is there. So now you check number index map contains second number. Then second numbers index this one, and this is not needed because we have already pushed everything into the map here. So there is no need to add that one here. So here one for loop here to add all the numbers, and here another loop to add all the numbers. Okay, if you see the time constant here, to add all the elements to it, it will take order of n, because n into order of 1, n elements we are adding. So each adding one element will take order of 1. So n elements we are adding, it is order of n. Here also the time complexity is we are iterating n elements, and in each iteration, while so in each iteration the time for each iteration is order of 1. So the time constant here is order of n. So the net the time complexity is order of n for this method, or for this method also the time complexity is order of n. The space complexity wise, here we are using one memory, one hash map with storing all n elements. The time complexity also will be time complexity will also be the order of n, as well as space complexity is order of n. Okay. Now let us add a test case for this one. Okay. Now let us go to this main method. Let's delete it here. Here say int array, you define numbers array. Okay, numbers equal to say 2, 4, some 9, some 20, some 70. Okay. and int target equal to some 70 plus 2, 72, say 72. Okay. And now create to some problem instance equal to new to some problem and to some problem dot find indices of v1 with the numbers and target. Okay. So here the results int results v1 equal to okay. Now it can just print some dot out dot println indices are and string dot format. We need to print two elements, right? So we can use percentage %d and percentage %d. Results v1 of 0, results v1 of 1. Okay. So let us run this one now. So here on syntax error. So now run it. So the indices are 4 and 0. Okay. So 0, 1, 2, 3, 4. So the fourth index element is 70. The 0th index is 2. 70 plus 2 is 72. And you can just do the same thing with another method as well. Okay. So integer array else v2. Here if you say can call v2 and this will also give you the same results. Okay. And here we say results v2. Here also we say v2. Now if you run it, so 0 and 4. Okay. So here it is just printing the things in 0 and 4 because we have already added elements in the first place, so it is coming at 0 and 4. Anyway, this order doesn't matter. So as long as 0th element and 4th element summation is equal to the target. So that's the thing. And if you want to add the test cases through JUnit, you can add the JUnit here. Dependencies, you can add dependency group ID or dot repeater and 590 version similarly. JUnit repeater API is there. API engine we need to add. Similarly, API you can add. Once you add these three dependencies, you can just add the test cases directly here. Okay. So just do some problem. So create a test case here, new Java class. So do some test and you give the same package. So you create that package here, move to. Okay, so the package got created. Now you can just add a test case here, just a test. Now, so here, before even doing this, you just have to say project build project. So it will download the dependencies for that. Now we can say test. Alt enter. Okay. So you can say build do some rebuild project, or you can go to this target mode. So okay, so now what you can do, right click here, Maven reload project. So it will download the artifacts, then it will become available for the test annotation. Okay, see, now we can just add test. Public void is the standard signature. Find indices v1. Okay, so now here you can just do the same thing whatever you did it here. Okay, so now possessions dot array, that array equals to new int 0 and 4, right? So results v1, results v1 here 4 and 0. So now if you run it, you are done. It will make sure that it's got tested. Similarly, you can add another case for that v2, just a v2, and he can call here v2 method. The order is 0 is the first one, and the second one is the 4. And results, we can say v2 as well as v2. Okay. So that's it. So this is one of the interview question. It is very easy question actually. So it is better if you know how to deal with it. So the time complexity is order of n, and the space complexity is order of n. Okay. So you can find the solution already in the GitHub location, which I have mentioned here. The solution is already present with both the approaches here in the GitHub one with the main method, as well as in the second one, that is in the test cases as well. Okay, that's it. Thank you very much.